Okay, so
I know, it's okay. We need one there.
you got this written already? Alright, so I gave you a homework to calculate the distance between two coordinates, right? You were supposed to pass 4 doubles. In reality, you can make it like this. You can make a structure that has 2 doubles, a latitude and a longitude. So you can make a method that instead of taking 4 doubles, it'll just take 2 coordinates. Make sense? Easy. So I gave the example there for the wall. But in reality, the wall doesn't do much by itself. Let's say I need a room. And the room is going to have 4 walls. Right? So I can declare, because now it's just a data type, I can use it as any variable. And I just call it wall A, wall B, wall C, wall D. And I call these room. And then, of course, assuming this is on top. Then, I want to make a house. Can make another type then. And this one has a master bedroom, a guest bedroom, and master bedroom 2 maybe. It's a 3-bedroom house.
This is all above the main, right?
And I call this house. So if I have my int main here, have my main, I can declare my house, a variable of type house. Call it my house. And then I'll say, well, in my house, the master bedroom, wall A has a width of 25 feet. So I asked access each attribute of the structure using the dot. Well, my house is a structure over there, and the elements are just type rooms. The computer just doesn't know. That's a different data type. It just allocates memory, and I say master bedroom. It's there. Well, master bedroom is actually another structure. Okay, so I dot, and there's the room. The room has walls. Okay, and the wall, there's width. And then you realize, if you were to do this in just primitive types, you're going to require a lot. It just gets really convoluted really quickly. Because let's say you have a 3-bedroom house, then you're going to have, I don't know, 3 times 4 walls, that is 12, so you got to declare all 12 times all 3 dimensions. And then you're going along, and then you realize, oh, I forgot to paint the walls. I need to add color. Oh, that's easy. I'm just gonna put color A, color B. I just change my wall. And then I don't change anything else. All I gotta do here is my house. I put color A and color B because the other side of the wall might be different color. My master bedroom, wall A, as a color, it's gonna be red. So I'm gonna put 255. That's a red. Did I change the others? No. I needed to make a change. I only made the change in one place. It was in the wall. Everything else got automatically updated. That's called object-oriented programming. You make these objects, and you don't have to go chase around to make a change. You only change it in one place. And then you realize, well, actually I got a house of 3 boxes. I'm like, what do you mean? You never made a door or a window, they're just boxes.
Jail cells.
I'm like, oh crap. All right, let's add in the wall. Let's put a boolean here. You know, let's say has door. Okay. And then at least one of the walls need to have a door, right? So a master bedroom, a wall B has door. So how does this happen in memory? I'm going to erase this side. So It's mass stack. So when you go take the Java or object-oriented programming, now you know why. So when I declare my house, it's not gonna fit here. All right. So when I declare my house, the computer already saw the structures before. So it says my house. Well, how much memory do I need for the house? Well, the house has 3 rooms. Okay, how much memory do I need for each room? Oh, got 4 walls each room. Okay, and each wall has 5 ints and a boolean. So when I declare a wall or declare a room, the first thing it's gonna do, okay, I'm gonna assume this is a wall, just this much, because I'm running out of space. Right? So this is wall A inside the room. And here is wall B. Let's use another color. And in each wall, there's the int height. Each one has the height, width, depth, color A, and there are ints, of course, color B, and has door. Same thing in this one. Each one has their own height, own width, even though it might be duplicated. Then you got wall B. I'm sorry, C. And then it's wall D. And then the computer sees this whole thing as one room. So this is room, master bedroom. And then it repeats the process. There it goes, wall A again. And then it goes to wall B for the next room, you know. Keeps going. Goes up and keep going. And this will be guest bedroom, so this is room, guest bedroom, and then it adds the master bedroom too, and then all of that combined is a house. All right, so what really the computer did is when he sees a house, it's gonna go and say, a room has 4 walls, okay. and a house has 3 rooms, so that's 12. So I'm gonna need 12 times 5 ints, and 12 times 1 boolean. So it's gonna have 62 integers and boolean, and they're gonna go all next to each other in the RAM. So it's gonna grab that big chunk just for one object. I could have a subdivision of houses. So what's happening here, this is all a contiguous amount of memory. So the computer might start having issues trying to find a spot that fits all that. I mean, now RAM is not that scarce like it used to be. That's why 64-bit programs, operating systems work better, because you get more memory. But anyway, what will happen if you run out of RAM? You start using your virtual memory. And then computer slows down and what if, let me change this just a bit here. Well, you gotta include the name of the student. Well, we learned last week that array of characters are simply, you can change it with a pointer, and I'm just gonna use a pointer to a character. I'm gonna call this name. So now, well, that's a pointer, it's not an array of characters. Yeah, because I'm trying to save space in the RAM. Not space, but more like, don't want to get that big chunks of RAMs. And now you're getting all these pointers inside of structures. The operating system is supposed to take care of all that. And that's why they call it RAM. It's all random. Trying to find the next spot that something has enough memory to your next object and so on. So, when we go to your Java class or your C# or C++ object-oriented, we're going to talk about classes a lot. C has classes. Notice that in here, my house, I just did my house dot master bedroom, right, and access the. Well, there's another type. That's called class. If you change that, it's going to give you an error. It's going to say, I cannot see the master bedroom. You're like, why? What's the difference between a structure and a class? It's very simple. They're the same, in essence. The difference is, in a structure, you can see all the elements by default. So we say they're public. You can access them. But in a class, everything is private. We can't see them. How can I make something public in a class? You have to say public. And anything that's under public, now this works. And if you want to make something private in that structure, the word private. And then anything below is private. So basically the class and the structure are the same. It's just by default in the structure everything is public, and in the class everything is private. But you can change them by putting labels on top. So why would you do that? Why wouldn't you just let me do stuff like this? You will learn in the Java class. I'll do it on Thursday too here, but I won't keep you in suspense until next semester. And now you will be able to have quiet holidays thinking, how does that work?
Definitely would be on the mind.
So, when we have a structure here, there are primitive types. But here, we have a structure that has other structures, or other objects, we should say. We use objects. Other objects as members. So this is called aggregation. Aggregation is when you have a structure inside another structure being used. It's not like nested if statements, it's just a structure that it has a variable. We don't call it variables there, we call it member variables. That is another structure. Easy stuff, right? See, if you hang out in this class until past the midterm, then your classes start getting interesting. And the midterm wasn't that hard. All right, so although it took longer than I expected, we used the hour and a half that I thought was gonna be plenty. So, questions in this? Nope. All right. So, ready for homework?
Yeah.
Too bad I don't have one for you. Actually, I did. Right, so, but I had to type it. The next thing I have to show you is when we make methods inside the structures or the classes, which we'll do that on Thursday actually. So for instance, in your rainfall program, you could have made And then you call this one just month. And then you could use just an array of months. So in your main, you could have done month. And then if you sorted the array by rainfall, then the lowest, element 0 will be the lowest and element 11 will be the highest rain. So, let's pause this. There's something else I want to do before I move forward.